Valerie's with Intel, you just saw her. She's the 5G Infrastructure Software Platform Director. Aaron, come on up. Aaron's with ClearBlade. He's the CTO. They're a platform company, software platform company. And Adrian. Yo, Adrian.
How are you?
Here he comes. Adrian spoke earlier. He's with TI. He's the Microcontroller Development Experience Manager. That's pretty spooky stuff. So I'm with James Brehm. We're a Internet of Things market intelligence organization. Our homework assignment is, if you will, to monitor the edge to the enterprise. Keep our finger on the pulse of the market. Today we're going to talk about the intelligent edge. And what I like to say, the tyranny of cost, latency, and security is going to drive a more intelligent edge. That's the subject matter of today. And we have an interesting dynamic. We have TI and Intel who are putting the capacity and the capabilities into the edge on one end of the spectrum. The other end of the spectrum, we have ClearBlade, who's a software platform organization. They're the folks talking to the edge, capturing the data, analyzing it, generating the actions, the alerts, reports, and interfacing with the enterprise. And so understanding their two perspectives and how they play is going to be pretty important. With that, I'm going to ask each to spend a few minutes just introducing. Does it make sense to go through your presentations, given what you did earlier?
No.
No? No? So with that, then let's have ClearBlade come up and talk about, can you pull up the ClearBlade presentation?
You need us to take that mic or hang on, hang on. That's your overview slide there. Okay. And 5 minutes is 5 minutes. Over, yeah. The bar's open, so folks are already ready to hit the bar one.
Okay, perfect. So I'm going to do a real quick overview of ClearBlade. This is a great setting for ClearBlade because very often we'll have these awesomely deep technical meetings with folks like Intel and TI and other hardware folks, and we'll have 4 whiteboards. And I'll start on one side of the room, and I'll write and write and write all the way towards the middle, and they'll start on the other side of the room, and they'll write and solve hard problems all the way up. And when we finally get together and draw a line that connects these two worlds, it's right here at the edge. So this is a fun conversation for us because it's always, there's so much domain across both sides. So if you can, I think I have a button, right? So just to frame who ClearBlade is we're an enterprise Internet of Things software company. So we don't do the hardware. We don't do the services around building a solution. We are pure software for large companies or enterprises to begin to build and adopt IoT. And they very often use lots of hardware from the folks up here and other vendors of hardware. They very often use lots of cloud and different alternatives there, but ClearBlade can sit and work across those ecosystems. What we see is a lot of really interesting use cases, both in the industrial manufacturing space being built on top of ClearBlade. We see interesting use cases in managing transportation use cases and how are we going to better serve and move products and goods around the world. Biometric identifications and authing, all that kind of stuff, all then tie into some of the smarter building and asset tracking behaviors. So there's a lot of flexibility of what people are doing on this ClearBlade platform as its IoT core. So that's kind of where we start our conversation, but these solutions get much deeper. And there's two really elements that have to exist from when you start talking at the very low level to these devices. TI had an awesome device up here earlier. Lots of folks are making new cool devices. They're doing awesome things like encryption, but there's also lots of devices that have been in the field for years with very different profiles. So there's a whole ecosystem of both open and proprietary devices. And then, of course, at the top, there's all the systems that have been running our world for years and years and years. And so that's where ClearBlade helps. We help with the software that has to live in between these two environments. The ClearBlade Edge is a real focus of what we're talking about today. And then our platform that runs in server-side or cloud architecture. Horizontally scalable, code-tenanted. But those are the two places where we're offering product. And then ultimately, there's a few core elements that we see. And especially at the edge, when you talk about adding intelligence to the edge, you have to start moving a lot of that core functionality that we thought we might do in the cloud a year ago, 2 years ago. We start moving all of this closer and closer and closer to the actual environment. So when you talk about core elements, you have to talk and adapt across so many different protocols. Adapters are core to how you begin to build these solutions at the edge. So you can not only talk the new Z-Wave and Thread or Zigbee, but you also talk OPC UA and SOAP of the systems of the past. If you think about that, when you have all these new devices, you have to begin to build the security in. Security layer becomes a fundamental part. And then at that edge, so we give that profile early on, and then we think about all the core elements of application logic that have to happen. Whether it's data, it's integration, it's messaging, it's logic, serverless logic. Being able to do all that stuff at the edge becomes incredibly important, and then talking back to your systems. So that's really where ClearBlade provides a lot of very unique value of how do you put this logic, this data, all the way down on the devices running in the ecosystems at the edge, doing your machine learning. The other interesting part of this is it's one thing to have function, but it's also how do you coordinate this gigantic mess, right? So if we start putting edges and gateways that are smart and intelligent in thousands of facilities, in millions of buildings or hundreds of thousands of buildings, how do you coordinate that, right? There's got to be a kind of a parent-child relationship between the objects and the data that's being moved through. So that's the other piece of really where ClearBlade solves a real challenge for our customers is how do you build these solutions, strategically decide what logic is going to run all the way down at an intelligent environment or what's going to run all the way up into our cloud server-side infrastructure. The final piece of that is how do you keep all these things in sync and how do you meet so many requirements of where do you want it to run. That's where a lot of value prop comes from ClearBlade in that you can run on any cloud. You're not necessarily tied, so if you like Amazon today, you run on Amazon. You like Google tomorrow, you can move that workload. So a lot of flexibility in that, or if you decide to invest in your own infrastructure, you can leverage that. But it all comes down then ultimately, how do you sync that and move that functionality also to the edge? And so there's a lot of capability in strategically moving that information down. Ultimately, we attack the problem like developers, not a drag and drop or flow style. It's about how do developers solve this very hard problem in a very hard world of industrial IoT. That a pretty decent overview?
That's great.
Okay.
Thanks. So let's move to questions. There's some water there for you. Valerie, why is the intelligent edge important?
So I think it's on.
Got it.
The intelligent edge is, in order to connect, first there's several things. First, all of these different things getting connected. If we don't do edge computing, the backhaul gets too congested. It could, I mean, if you're thinking about 60 billion things getting connected, the backhaul's going to break. So if only to do initial analytics or processing at the edge, the edge has to get more intelligent. Latency is another concern. A lot of these applications require real time. And to have a better quality of experience, reducing latency is becoming more and more important. As consumers, we've already taken, you know, our phone has gotten so personal. As enterprises, the network is now getting very personal. Where are their mission-critical applications? How fast can security be enabled? And even public safety is another use case that is becoming more and more latency sensitive. Being able to do machine learning and deep learning or artificial intelligence at the edge is becoming more important if you're thinking about things like autonomous driving or even assisted driving. Smart cities need real-time information to redirect traffic. So all those different types of use cases are demanding compute at the edge.
Okay, so the intelligent edge makes sense and there's demands for it. What are the semiconductor and silicon vendors doing around tackling these concerns and putting these pieces in place? Adrian, maybe you can talk to that.
Sure. I'll hit on that one. So what we're trying to be is sensitive to the developer. We understand that low power, for example, is something that's very critical. I feel like in other aspects of creating innovative products, power and battery life is what we simply can't keep up with, right? So what we're making sure is we're providing portfolios of microcontroller products that can operate on a coin cell battery, that can operate on a AA battery, or in many cases, energy harvesting. So making sure we're providing ultra-low power products is something that I think enables you as innovators, and making sure that the ultimate end customer has solutions that will survive a really, really long time. And this goes back to why the intelligent edge is so important. What we're seeing in a lot of these demos here are basically raw sensor data being piped up to the cloud, and that's where we do some of our sort of intelligence. That's where our if statement is. And I think that's okay in some cases, but in many cases, we really want to do that if statement locally at the edge, right? That minimizes how often we're connecting to the cloud, which ultimately leads to better battery life in many cases. And then also latency is a really big deal there. If I can make that decision without having to send my data up to the cloud and wait for a response, that's going to be critical for industrial applications, medical applications, automotive applications, etc. I'm not sure if that's me or not.
Great. Let's talk about it from an application perspective. What are design issues you got to think about?
So the design issues related to using the edge. Is that me?
It's getting worse. Okay, that's bad.
Oh. Testing. Am I working? Okay. So design considerations. So there's always a question of what do I put on the edge versus what do I put back in my platform and in the cloud, right? You have to answer that question. And the first answer I often tell customers and folks we're working with is you're probably not going to get this right. So you need to choose solutions that let you very rapidly change where that logic may or may not run. There are levers to how you decide to what you're going to put where. The first thing is if you need something to run very, very fast, then that's an API that makes sense. You need to move that logic, that if statement, all the way down if it has to run very quickly. The other thing that is kind of along those same lines is if you have to guarantee uptime. No matter how good the clouds get, no matter how much better my internet connection is at home, it still goes out and still drives me nuts. And that's a pain for me, but that's awful for a factory that just shut down production. So I say not only is if you want it to be fast, but if you need to guarantee uptime, then that's something you want to put down at the edge. There's a few other pieces that we bump into quite regularly, and that is integrating at the edge. And it's kind of like behind the firewall integrations. Are there pieces of data that you want to talk to, that you want to access? There's logic into those systems of record. And so that's another spot where the edge becomes incredibly valuable for you to begin to not only maintain uptime, not only get the performance, but then also do the correct integrations. And the final piece you've already talked on is how do you prevent that gigantic backhaul? How do you stop from having gigabytes of ingress and this huge cloud bill? Well, you do that by basically studying and grooming that data before it fires off to the cloud.
Yeah, and if I could just add one thing to that is it's also dependent on the application, right? If you're trying to do a huge application on a small device, that becomes unwieldy in some cases, right? So there's another need for doing the application at the edge. And if you want that application to run in real time, there's still a lot of things that can be run in the cloud, no problem. But at the edge, you're going to get a better quality of experience, and you can do a lot of these deep learning at the edge and therefore get the real-time aspects of it.
Adrian, is this one working?
Yep, you're on.
Adrian, what are the semiconductor folks doing to make it easier for the developers to connect to the cloud?
Yeah, good question. So at TI, the main thing that we're starting to realize is with the Internet of Things, there's really two types of developers that are starting to interact with each other. There's the more hardware-savvy developer that can spin out a board, a schematic, a layout instantly. Then you've got the other group of folks who can whip out an iOS and Android app within 24 hours. Those are two completely different mindsets, two completely different audiences that we as semiconductor providers have to be sensitive to. We have to understand that we need to lower the barrier of entry from a hardware perspective for the software guys, but then also lower the barrier of entry for software for the hardware guys. And it's not an easy problem, right? There's two completely separate requirements that have to be met. And I think at TI, we're trying to address both of those. So I'll hit on each of what we're kind of attacking for both of those customer bases. For the hardware savvy guy, we're working with folks like IBM Bluemix and making sure that Node-RED works, because Node-RED, if you're familiar with it, is a drag and drop JavaScript programming tool. I don't have to learn how to NPM my own modules. I simply drag a module in, and I can immediately start sending a tweet whenever sensor values exceed a threshold. Flipping that around for the software savvy guys, all of our hardware is open source. So if you actually look at a Launchpad development kit or a sensor tag or whatever hardware kit you buy from our e-store, that's all done with an open source license. So the schematics and the PCB design files are available for you to download, and you can use that as a reference design to understand how we did our antenna design. And that way you can leverage our system level expertise from a hardware perspective and kind of have confidence that you're working with known good hardware. And at that point, you can focus more on the application side of this in the cloud.
Aaron, talk to us about security.
So when you first start looking at security, on one hand, we certainly find that device manufacturers are doing a lot of cool stuff on their boards built in now. So that's fantastic. But that diagram that we threw up, where we suddenly have now added another layer of complexity to our IoT solutions, more complexity creates more opportunity for us developers to screw things up, essentially, right? So definitely that additional complexity at the edge is something that you really have to address out of the gate. You talk about kind of the audience that you're talking to, these makers, these kind of stuff. They've got to do it, but at the enterprise level, it's got to be really addressed, hard-baked out of the gate, right? And it can't be homegrown. They've got to really do this stuff. So for us, when we look at the edge, is it's actually, because it's intelligent, it's a chance to actually hammer down and lock down the security model that needs to happen. So many of the devices that are coming out of the brownfield environments have no security, no auth model or whatever. The edge is that opportunity to put that in place. The ability to leverage what these new devices are doing by default with encryption, that can be brought right in, but really given the ability to add the encryption if it needs to be there, presenting an auth model so that you can identify and authenticate the user or the device, building the authority layer so that your old Allen Bradley machine can't update your home address for where you get tweeted to. Building that model has to be done, and the best place to do that is before it travels across the cloud, before it goes running up, into other cloud. It's there at that edge, and so that for us is a really great spot. And the last piece is if you do have enough compute, then you start looking at, can we audit what's going on? Can we audit the behavior at that gateway before it runs away? And so it's a little scary to have a new piece of our architecture to deal with, but it's also incredibly empowering to solve some of those problems before they run up the chain. At least that's how we're viewing the opportunity of what the edge can give us.
I think that makes sense. Valerie, what intelligent edge solutions can we expect to see today, and what should we anticipate in the future?
Wow. So it appears like, at least from the perspective that we have, a lot of enterprises are very interested in deploying edge edge computing capabilities. We've seen things from airlines that want to get data off the airplane and still meet their turnaround time. They can't do it today. And so Wi-Fi doesn't work for them. It has to go to cellular type networks. There's even casinos want to be able to put these edge computing capabilities into their casinos. So gaming is another one. So when you come out of a concert and you have a specific profile at these casinos, then automatically the games change relative to your profile. So the enterprises have all these different ideas of what to deploy. We hit our head up against the wall for a couple of years thinking, what's the hot app? What needs low latency? What is it? What's going to drive the next big thing? The enterprise, they have it. They know what they want. They either have the application or they know where to go get it built to get it done at the edge. Even I was approached by the Association of Cardiologists, and they said they were interested in getting edge computing at the hospital for two things. One was training. During surgery, live surgery, they want to be able to send those images and control those images to where they're sent, to different devices in real time. And as paramedics are coming into the hospital, they want to send procedures or have a look at the patient that they're bringing in. So these different types, I can't say for sure which ones are going to be deployed first, but they're being deployed. The oil refinery is already deployed. So those types of applications are starting. It seems like they're coming in bursts, but the applications are being written today.
Thanks. Anyone in the audience have a question?
So with these types of edge deployments that you're discussing, is the data staying and being analyzed at the edge or then being back to the cloud afterwards for redundancy and safety?
Primarily, we're seeing the user data, the data itself is being processed at the edge. The enterprise has their own, can have their own regional data center, and in that case, it gets placed there. There is semi-private networks where they do a lot of the processing at the edge, but then afterwards it goes to the cloud. It depends on the enterprise.
But are there some where the data just always sort of stays resident at the edge?
Yeah, well, it stays resident at the enterprise, yes.
So that's a little less secure, right, than having it off-site at a secure facility? I mean, in some senses?
I think the same security algorithms can be applied, and from the enterprise perspective, it may be more secure if they keep it on-prem.
Okay, thank you.
So one add-on thought to that, where we've seen it is, we actually see our customers sending the data up, and then they will learn from that, and so it will go to a cloud, but then they'll actually, once they learn, they'll implement the Bayesian methodology or the neural network all the way down at the edge so that they no longer need to send that data up. So it still can be advantageous for a brief period of time for all of that data to change, and maybe it's just an if statement. But as you learn enough and you can change and you can begin doing that AI, you move that logic down. So that becomes a pretty powerful way to dynamically shift that workload from the cloud back to the edge.
Hi, any other questions from the audience? Any other points of application you guys want to make?
Let's see here. Probably one other thing I'll mention is simply how much is changing in the embedded space. I think imagining a 16-bit, coin cell powered microcontroller being able to do voice processing, even just 5 years ago, that was something that was impossible. The fact that these little tiny devices can operate with a coin cell battery and do some of the algorithms that we previously needed a centralized server for, it just opens up that possibility. It allows us to turn those knobs where we can actually do more at the edge if it makes sense for your application. And I think that's something that's super, super exciting. One of my favorite examples is the Amazon Echo, right? We're not sending every single spoken word up to the cloud. We're only sending it up once that certain catchphrase is heard. That certain catchphrase, that's being recognized by a low-power microcontroller. That's being able to basically do some of that algorithms. It's not going to discern every single sentence you speak to it, but it's able to recognize that 2 or 3 words, and only at that point does it employ the cloud for recognizing some of the other speeches and queries. So I think in the next couple of years, we're only going to see more and more powerful end microcontrollers, and it's only going to provide more flexibility to you as a developer. Now you have more options in terms of what you want to do at the edge versus having to use the server simply because you had no choice at that point.
So I'll echo that statement. I had an IoT director at a Fortune 500 as a customer of ours. He sat down and had to give a board presentation, I guess back in October of last year. And he sat down and he said, I know no one in this room has ever heard this word before, but the most strategic direction of our company is edge. And he said, it's because not of what we can do today, we can do all our version 1 implementations of IoT. It's all of the new stuff, all of the new capability, recognizing faces, all of this stuff that we're going to want to do comes from having an architecture that includes the edge out of the gate. And really that decision drove a lot of their mindset of how they move forward in their solutions, not only today building just kind of the version 1, but planning and iterating for that logic moving back and forth. So definitely iterate that. We have no idea what these guys are going to build next that we're going to have the ability to code and build around. So giving yourself that fluidity is awesome.
And I think from our perspective, we're seeing the ability to do several things on the same type of platform. Being able to create a whole venue of services at the edge is something that a lot of enterprises are looking for. We had this one deployment where it went through a field trial and it started getting deployed, and the IT division decided we're going to put up 26 more applications. We don't know what they are. It's just like getting your laptop and you install a bunch of applications. The person who sold you the laptop has no idea what you're putting on it. It's yours. The same thing is happening in the enterprises. It's quite interesting.
Well, folks, that brings us to the edge of the presentations, if you will. Thank you very much. We certainly appreciate it. Let's get a round of applause for these folks.
Thanks, everybody.
Thank you.
Thank you very much.